Mr. Joe Fody. This is our first video together.
I know, it's pretty exciting.
It's so exciting.
It's a dream come true.
I know. For me as well.
Yeah.
For me as well. Okay, we're going to solve this puppy.
Sick.
Yeah, absolutely. So we're solving for x. You know, there's so many different ways to do this. But we're going to solve it in the way that I think our students here at New Paltz are more familiar with.
The 2018 version is what you're saying.
That's right, exactly, exactly. So if we're looking at this, whenever we're solving for x, we usually like to isolate x on one side and get everything else on the other.
Right, it stands to reason.
Yeah, all right, so I'm just going to start dividing. I'm just going to divide the 6, right? So I have 2 to the x equals 5 times 7 to the x. Oh, okay, so I'm almost there already. So if I want to isolate my term with the x, what do I want to move over here?
I'm going to guess the 7 to the x.
Yes, let's divide the 7 to the x.
Now you're able to divide something like that even though it's raised to a power?
Well,
it doesn't change the rules at all?
It doesn't at all. I'm multiplying. Whenever you're multiplying things, you can undo them by dividing.
Cool.
Great question. So now I have 2 to the x over 7 to the x equals 5, basically. And now, this is interesting. If I have 2 to the x over 7 to the x, can I conclude that that's the same as 2/7 to the x?
I would say yes, because there have been many times where we've done maybe 3/2 squared. We know we square the top and square the bottom, so basically we're just going backwards.
Exactly, that's great. 3/2 squared, as you just said, well that's 3 squared, 2 squared, right? So we're just going backwards. That's exactly right. All right, I have to get an eraser. Okay, so now it's not too bad. Now we have this in our nice form. I can just rewrite this in log form. Log base 2/7 of 5 equals x. Hey, did I isolate x?
You did.
I solved for x. Now, I don't have a calculator, but you could find the decimal equivalent of that by putting that in the calculator as is, or using the change of base log of 5 divided by the log of 2/7. Cool.
Looks great.
All right, should we try another one?
Yeah.
Fantastic. So, what if I had something like,
Whoa.
something like this?
I don't know, it looks a little spooky.
That does look a little spooky.
It's not just
there.
x on that left side there anymore.
I know. Well, let's proceed. Let's just try to isolate x.
All right, let's see what we can do.
All right, let's see what we can do. I'm just going to divide both sides by 12 just because I'm in the mood. I mean, it doesn't matter. I could have divided by 4.
Right.
Okay, so that's 5 to the 2x minus 1 equals 1/3. All right, don't freak out, people. I know we can handle fractions. All right, 1/3 times 5 to the x. Well, should we do what we did before?
Let's give it a shot,
Yeah.
see what happens.
Let's divide both sides by 5 to the x. Again, our mission here is just to get our terms with the x on the same side.
Right.
Okay, so, gosh, I can't do easily what I did before because my exponents are different.
Yeah, can't quite just pull it out.
But
A little fishy.
what do you see that's the same now?
It does look like the base is the same.
The bases are the same. So I think I can do something there. So let's zip over here and think of when our bases are the same. Like if I have x to the 5th over x squared, I can simplify that, can't I? What does
Yeah.
that equal?
I do believe it is x to the 5 minus 2, or in other
Yeah.
words, x cubed.
Yeah, am I still on the screen here?
Yes.
Yeah, because really that's just x times x times x times x times x over x times x. Boom, boom, you're left with x to the 5th.
Whoa. You mean to tell me that's why you subtract? It's because
Yes.
you're just dividing through and canceling out some
Yeah,
x's?
and that's why these rules, like when the bases are the same, you just subtract the exponents. Yeah, that's nice to remember, but I always like reminding myself that just is x times itself 5 times, divided by x times itself twice. X divided by x is 1, That's why that little rule works.
Makes sense.
Isn't that cool?
I find it interesting that you're able to do that with letters and not just numbers.
You can do it with numbers.
I know, I'm saying as well.
Yeah,
with letters.
right. Oh,
Yeah.
right. Exactly. Okay, so what do you think we can do here?
Well, based on your previous example, I would say we set it to be 5
Yeah.
raised to the 2x minus 1, all subtracted by x.
Yes. Isn't that groovy?
That's great.
Okay, so I have a 1/3 here. All right, I think I can simplify this. I'll zip this up here. So that's going to give me 5 to the, let's see, 2x minus 1 minus x. I think it's just x minus 1
Seems right.
equals 1/3. Hey, do you see what I see?
I do see what you see.
That is just something I can rewrite as a log. Log base 5 of 1/3 equals x minus 1. Hey, have I isolated x?
You have indeed.
Almost.
Oh, that's true.
What do
Well,
we
it's a
have
good
to
thing
do?
you're going over this. Otherwise,
That's
I'd
right.
make more mistakes like this in the future.
What do I have to do here to get x by itself?
You got to add 1 over on both
Add
sides.
1 to both sides. That's not a big deal. Add 1 equals x. Now, I just want to say something. You know, there's so many different ways to solve these log equations, and the answers might look different, too. You know, we could have solved this and gotten an answer that looked totally different, but when you put them in the calculator, you get exactly the same decimal. We'll talk a little bit more about that in class.
Sounds good.
So if you solve an exponential function, you get an answer and you have it in log form, and you look at one of our answer keys and you're like, I did it wrong. Maybe you didn't.
It's good to always double check.
Absolutely. Hey, I'm in the mood for a natural log. How about you? Let's do one of these with e. I always use the same numbers. Give me a number.
16.
16. All right, let's say 16e to the 2x minus 1 equals
4.
4 times e to the x plus 5.
Uh-oh.
Uh-oh. Let's solve this.
All right.
What do you feel like dividing by, Mr. Fody?
I like doing 16 over 4.
Okay, good. Very nice. Let's divide by 4. Doesn't matter. Boom. So that gives me 4 times e to the 2x minus 1. Okay, again, we're solving for x. Let's try to isolate the x. Let's bring that puppet over there by dividing. Everything is, as we did before. Oh, okay, so what situation do we have here?
Well, we've got a common base,
We do.
and each of those bases has its own exponent, which,
Okay.
as we saw before, we can just subtract.
Fantastic. So it's going to be e to the x plus 5 minus, I'm going to be careful here, put that in parentheses, right?
Right.
So that's going to be 4 equals e to the, let's see, that's going to be x minus 2x, which is minus x. 5 minus a negative 1, that's really 5 plus 1, so 6. Did I do that okay?
Looks to me like it's good.
All right. Hey, I can just rewrite that in log form. Let's do that. Now, this is what some students did today, which was perfectly correct. They said log base e of 4 equals negative x plus 6. That's perfectly correct. But we happen to have a special symbol for log base e, and that is
The natural
the
log.
natural log. And we call it natural log because things out there in nature that grow or decay exponentially are doing it continuously. So they always involve the number e, and a log with a base of e is called natural log for that reason. Okay, hey, I'm solving for x. I need a little more work. You know, I'm just going to bring my x over here and subtract my natural log of 4. Is that all right?
Looks good to me.
Okay, fantastic. Yeah.
Great.
Hey, somebody did this, or a problem like this today, and got this. Wait, can those be the same?
I think it can.
They are. Think about why those are the same. It has to do with log properties. We're not going to talk about it right now, but that's just an example of how these answers can look.
Certainly something to ponder.
Yes. All right, how are we feeling?
I think it's pretty good.
Okay. Should we do just one more?
Yeah, let's try one more.
All right. Let's do one. That 16 gave me this idea. Let's say we have 16 to the x over 2 equals, I don't know, 7 times 3 to the x.
Okay.
Okay. Solving for x. So let's get my terms with x on one side. I only have one constant, so that's already good to go.
Yeah, we don't need to do that extra step.
So divide by 3 to the x?
Sounds good.
Okay. All right. Oh, okay. So I'm a little stuck here. My bases are not the same. And my exponent isn't the same. So all the problems we did before, either the exponent was the same, and I could rewrite the fraction all raised to that exponent, or the bases were the same, and I could simplify. So what the heck could I do here?
Well, it does look like in each exponent there is an x term. Is there something you can do with that?
So in other words, you're saying, could I rewrite this?
Yes.
Yeah, okay. So the bottom, I think that's clear. That's
Yeah.
just 3 to the x. So x over 2 is the same as 1/2 times x, right?
Right.
So is it legal just to say that's 16 raised to the 1/2 raised to the x?
I would say so.
I think so. Let's just step over here and review those little rules. When you raise an exponent to another exponent, remember the little rule is you multiply those exponents. So x to the 1/2 raised to the x, 16 to the 1/2 raised to the x is 16 to the 1/2 x.
Interesting.
And the reason this works, we're going to just do what we did before. That's x times x 3 times. There's x times x times x times x times x times x. 1, 2, 3, 4, 5, 6.
6 x's.
Love that. Okay, so I'm feeling hopeful about this. What is 16 to the 1/2?
I believe, if I remember right, that when something's raised to 1/2, it's actually a square root. So I'm going to say that is 4 to the x divided by 3 to the x.
Beautiful. Hey, do you see what I see?
Loud and clear.
I see the same exponent. So I think we can rewrite this just like the first problem we did. 2 4/3 to the x equals 7. And one more step. Log base 4/3 of 7 equals x. Boom.
Awesome.
Yeah. And again, so many different ways to solve these, right? This isn't the way I grew up solving these.
Nor me.
Nor you, right? And you're a young whippersnapper compared to me.
Well.
But this is, as you said, kind of, I think, what students are doing now, and it's a good way to do it.
Yeah, I'd say so.
There are some, I'm not going to talk about it now, but there are some of these that you can't solve easily, that you might have to think back. Ooh. Something like that is going to be tricky to solve. That's going to be a bit of a challenge. But you can watch our next video to see how you could solve an exponential equation like this.
Same math time, same math place.
You got it! Thank you. This was fun, Mr. Fett.
It was great. Thank you so much.